Let's look at solving systems by graphing. So here's an example with a red line and a blue line graphed. We have their equations, and you can see that they both intersect at the point 2, 5. That's the general idea of what we're going to be going for in this lesson. Let's get ready. You're going to need your pencil, your notes, and we are going to look at some buttons on the TI-84 calculator, so grab that as well. For our agenda, we're going to solve 3 systems by graphing. We'll look at 2 special cases. I'll show you how to do one on your calculator. You should be practicing along the way and take notes on the last slide. So what does it mean? What is a system of equations? It's 2 or more equations. If you have 2 variables, you need 2 equations to solve for those variables. This is an example of what a system looks like. What does it mean to solve a system? Well, once you graph them, if they intersect, the answer is that point. So let's take a look at example 1. Here we have 2 equations. And what else do you notice? Well, I notice that they're both in slope-intercept form, so I'm going to go ahead and graph it. I'm going to graph the first one by going up to 6 and down 3. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. And I have that line, and that is my red line. And now I'm going to graph this one in blue. So I have my y-intercept. I start down at -4, and I move up to over 1 to get my blue line. And I should be crossing at that point, which is the point 2, 0. Make sure you're writing that in the correct order. X is 2, y is 0, and that would be my solution. Here I plugged it into Desmos. You can see a better picture of the graph. Reminder that the answer is a point. Let's look at these 2 equations in this system. What do you notice? Well, I notice the first one is not solved for y equals. So I'm just going to rearrange it. I'm going to subtract x from both sides, and I get y equals -x plus 7. So I'm going to graph that. I'll be up at 7 with a -1 slope. So I'm coming down, and I know I should hit 7 again. And I have that red line. And the second equation is already in slope-intercept form, so I'm going to go up to 1, which is my y-intercept, and I'm going to move up to over 1 for my blue line. And my point of intersection looks like that, 2, 5. Here it is graphed in Desmos. Go ahead and pause this. Try this one yourself. Notice they're not in slope-intercept form, so that would probably be the place I'd start. So when you rearrange, did you get y equals x minus 1 and y equals -2x minus 7? When you graph those, you get the answer -2, -5. Let's look at a couple of special cases. So we're going to graph the first one. These are already in slope-intercept form, so I'm going to go up to 4, and then I have a slope of up to over 1, so it would put me there. Remember, you could also go down 2, which is negative, and back 1, which is negative, and a negative over a negative is a positive, so that will work. And then I have this equation, 2x minus 2, so I have a y-intercept down at -2 and a slope of up to over 1. And what do we notice about those lines? Where do you think they're going to intersect? Well, when we graph it in Desmos, we get that. They are never going to intersect. Hopefully you recognize that because those have the same slope, they both have a slope of 2, then the lines are parallel. They will never intersect, so we can conclude that parallel lines will have no solution. Don't leave it empty because it shows that you don't understand it. Make sure you do make the conclusion that there would be no solution here. You have to write those words out. Let's look at example 5. I first noticed that they're not both in y equals mx plus b, so I'm going to rearrange the second one. I'm going to subtract this over. and I'm going to graph my first one. So I have a y-intercept up 1 and then a -2 slope. So I'm down like this, and I'm going to graph that line. Grab my blue tool, and I'm going to grab my blue line, and I notice that I am here and here and here, and I'm on the same line. So they intersect at all of those points. Interesting. Did you notice that? So if I graph it on Desmos, it was red and it was blue, so that's kind of a mixture, and that is a purplish kind to show that they are the same line. These are called coincident lines, kind of like the word coincidence, and they are going to have many solutions. And it happens because they were the same exact equation when I rearranged it. They had the same slope and the same y-intercept this time. Solving with the calculator. So here's our system. We've got this equation and this equation. And the first thing we need to do is we need to get it into our calculator. We need to be able to tell our calculator. So you are going to go to Graph, which is over on the right-hand top corner, and it should pull up this window. So you want to enter -2x plus 9, and when you use x, you're using this key here. This is your x. So you're going to do -2x plus 9, and then hit down and do 3x minus 4. So now you've told the calculator those are your equations. We can hit graph to see what they look like, and you should get this picture. But now we want to find the point of intersection. So you're going to use the intersect option. So you're going to hit the second button, which is this one, and then you're going to hit trace. So second, trace, and down to number 5. Second, trace, and then down to number 5, which is intersect. It will pull up a little spider, like a little blinking cursor like that. And you want to, this one says to enter 3 times. I prefer you to put your blinker, your cursor on the left on one equation and hit enter. So I want you to go left, enter. And then move the cursor to the other side of the point. Remember, that's the point we're trying to surround. So you're going to move your cursor over here somewhere. It should be on the other equation. So you're going to go right, enter. And then the calculator will say, do you want to guess? And you're asking the calculator to run it and hit enter. So that's why they're saying you can enter 3 times, enter, enter, enter. But I prefer you do left and right because it's going to help us move forward with other types of equations in the future. And down here is your answer. So we don't always get integer answers. We could get 2.6, 3.8. And that's why our calculator is going to come in handy because we won't find those answers on graph paper. So be sure you know where to find all of these buttons on your calculator. And to recap, we solve systems by graphing. This should all get into your notes. You want to make sure you write in slope-intercept form and graph each line. Find the point of intersection. Make sure you write your answer as a point. If the lines have the same slope and different y-intercepts, they're going to be parallel, so you can conclude no solution. If the lines have the same slope and the same y-intercept, they're going to be coincident, and they're going to have many solutions. Good job.